Okay, I wanted to go through some of these problems with you. I don't know if this is number 13 in your packet, so if it's not, you should go ahead and write it down. Let me apologize in advance for the handwriting. It's really hard to get used to this board. I'm using the airliner. Okay, here's where it helps to know your derivative rules. The derivative of tangent is secant squared. So if we let u equal tangent of x, then du is going to equal secant squared. Yeah. So when we look at this integral, we've got du in here, and underneath the tangent, we've got or underneath the square root, we've got tangent, which is our u. So we need to make this substitution. This will make our lives a lot easier. So let's go ahead and change our limits of integration. When we plug in the lower limit of 0, the tangent of 0 is 0. So our new lower limit will also be 0. When we plug in pi over 4 to our u, we get tangent of pi over 4, which is 1. So our new limits will be from 0 to 1. Now making the substitution, I've got the square root of u, which is the same as u to the 1/2 power. And then highlighted here, du. So this integral is a lot easier to solve than what we started with. So let's go ahead and solve it. We need to use the reverse power rule here. So we're going to add 1 to the 1/2. So we get u to the 3/2 divided by 3/2. And that's it. We just need to evaluate from 0 to 1. So we plug in the upper limit first. 1 to the 3/2 power divided by 3/2 minus 0. 1 to the 3/2 power is just 1. So 1 divided by 3/2 is 2/3. That's it. Make sure you know how to check these on your calculator by using math number 9. Okay, you should always do that if you have the luxury of having a calculator with you. Okay, that handwriting turned out really bad. Okay, let's try another problem here. Number 16. So number 16, I've got sine of square root of x divided by square root of x. I don't really like having a sine of a function here. I'd like to have sine of just regular x. So let's make let's let u equal to the square root of x, or x to the 1/2 power. Let's see if that helps us. What's the derivative of x to the 1/2 power? Right, it's 1/2 times x to the negative 1/2 power. You bring the exponent out in front, and you reduce the power by 1. Yes. Well, what does that really look like? That really looks like, if we rewrote that, it would be 1 over 2 times the square root of x. Yes. So now we've got du equals 1 over 2 times the square root of x dx. When we go back and look at our original integral, we've got a square root of x in the denominator, which is what we have here when we look at, oops, I don't erase it. It's what we have here when we look at our du. So, guess what that means? That means that we've got almost what we need here. We need to include a 1/2, and then everything will be perfect. So when I include a 1/2 on the inside, and we include a 2 on the outside, the 2 times 1/2 is 1. That maintains my integral. It doesn't change anything when I do that. Okay, now next thing I need to do is figure out my new limits of integration. So if I've got my first limit, my original limit was pi squared divided by 4. So the square root of pi squared divided by 4 is pi over 2. So my new lower limit is going to be pi over 2. And my new upper limit, the square root of pi squared, is just going to be pi. So I have the integral from pi over 2 pi. And my new function in here is going to be the sine of u times du. Now that's the hard part. The rest of this isn't too bad. The du is where you got to realize how we made this substitution. We have the square root of x in the denominator in our original integral. So in order to substitute in for du, all we need is the 1/2. So that's why we included the 1/2 up here in our integral and the 2 in our integral. So I need a 2 over here, and I'm going to evaluate this. Take some time and think about that, because that's the hard part here, is understanding what we're substituting and why. So the integral of sine is the opposite of cosine. Because remember, the derivative of cosine is negative sine. So I have the cosine of u, the negative cosine of u, times 2, evaluated from pi over 2 to pi. Okay, so we need to plug in. Let's see, let's go ahead and backdrop that negative 2. So we've got negative 2 times the cosine of pi minus the cosine of pi over 2. Okay, so we've got the cosine, negative 2, oops, negative, I can turn that into a 2, negative 2 times cosine of pi is negative 1, and the cosine of pi over 2 is 0. So I've got negative 2 times negative 1, which is 2. Again, always make sure you check your answer using the calculator. In the next recording that I'm going to do, I want to go over the last few problems from the packet.